about the product pricing, it's a bit unfair for us right now to talk about that because we haven't perfected the product yet and there is still a long way to go. But still, after having done a market survey, we realized that most of the black and white toner based or inkjet based printers cost about a maximum of 4,000, and the color printers go a bit higher, like 8,000 to 10,000, the basic ones. So we wanted our price to be competitive with the existing products because first of all we want more people to buy our products because first, as it has its own advantage of being inkless and the long term investment being very less, and secondly it's environment friendly, it doesn't generate e-waste, and it's much more reliable. So our product pricing that we are aiming to achieve is somewhere around 6,000 to 7,000, so that we don't make eyebrows raise too much, especially if we go about in the market saying that, oh, there's a printer of 15,000 rupees which is inkless. People would not be ready to buy it because 15,000 rupees at a time is a bit too big for the pocket. So we'd like to keep it somewhere around 6,000 to 7,000. For the fabrication of this particular model, a lot of the parts were salvaged, so putting a price for them is a bit unreasonable. For example, the chassis, the shafts, they were all salvaged out of old e-waste. However, new components like stepper motors, BLDCs and the 3D printed materials, the PCBs, the components and the rest of the electronics is priced at a given price. For example, 1/4 of a kg of filament, 3D printed filament, was used for fabricating the plastic parts as you can see in this model, and about 1,100 was spent for 1 kg. So about 260 rupees of 3D printed material is spent on a single printer. A single stepper motor costs about 800 and a BLDC costs about 400. And the PCB fabrication cost per unit costs about 450 rupees. And over and above that, other things like the wiring harnesses, the power supply unit and the chassis that will be put over this put together costs about 1,600 rupees. So putting all the hardware together, all that I have mentioned now adds up to around 4,000 rupees, and if we just normalize the cost of this chassis and shafts, it could be another 500 rupees more, max to max. So around 4,500 rupees is enough for fabricating a single unit in terms of hardware. But what about the services that are put into getting the raw materials, paying the people who are associated with us to fabricate this, for marketing and things like that? So we'll be taking a margin of, let us say, 2,000 rupees for catering to them. What is so different about this? What keeps it apart from the existing printers in the market? Well, this speaks for itself. Once we complete this product into a completely marketable printer, this printer would be like the Aladdin's lamp in the printing world. I mean, every office, every educational institution, every clerical worker will be having an inkless printer and wouldn't be bothered about inks at all. They can just keep going and on and on and on with their printing work without any pause or without any fuss of refilling their ink cartridges. Just imagine a world where there is nobody even bothered about their printer, whether it's full or it's empty of ink cartridges. There is no e-waste generated, there are no plastic waste generated, there are no small children working on recycling factories opening old ink cartridges, getting exposed to the toxic smoke, fumes, and more and above that, the investment that goes into a printer, if this comes into the market, is going to be way less than it is today. Because around 80% of the cost that goes into a printer is on the ink cartridges, which is to be refilled again and again and again. So it's just about 10% of the cost that goes actually into a printer. And this is just talking about 1 year. The rest of the lifetime is only on the cartridges. Nothing goes into the printer because essentially there's nothing in the printer that runs out except for the cartridges. Whereas in this printer, there's absolutely nothing that runs out. Another question that we were asked is, okay, once we are done with making this beautiful printer, how do we take it to the people? How do they get it from us? And how do we ensure that everyone knows about this? Well, the first of the approaches that we thought were e-marketing, digital marketing. We thought that we can approach to eBay, we can approach to Amazon, we can approach to Flipkart, give them a demonstration of our product, and strike a deal with them, and that's something that we found is strictly online. But when our faculty advisor and some of our colleagues took this idea, when they came to know that we are working on it, they had taken this idea to universities outside, organizations outside, companies outside, in the expos or conferences or hackathons where they share their ideas. Most of the people there who heard about this were very enthusiastic about having a hands-on experience using this and promoting this amongst their own peers and taking it to a larger crowd. Especially when professors and industrialists meet us, they are very keen on seeing this in working, and they wanted us to exhibit this product at their institutions and promote it there. So another means of distribution that we thought is by spreading the awareness and giving samples of this product, test samples or evaluation samples, call it whatever you want, to these enthusiastic people who would be demonstrating our product at their own capacity to a larger crowd, and the popularity, thus we believe, should propagate into the citizens' large mass. So we'll do that. Of course, now we have to keep the local distributors into the picture as well. The local distributor's prime concern is, of course, its manufacturability and its scalability. Scalability as in what local distributors feel is that we as a company must be ready to take on a sudden surge of demand that would come if they open such a product into the market. So they feel that to maintain their reputation, we should be able to supply them the number of units as demanded by the market. So let us assume that for now we have developed this product completely and made this product scalable enough that we are able to manufacture them in large masses. We found that given this guarantee, most of the local distributors are very optimistic about a product like this, and they were willing to try this out by selling it at their shops, by keeping it at their shelves and having a running demonstrations at their desks. So we are really happy about their enthusiasm, and we are looking forward to take it to them. Apart from the local distributors, our college, when they heard about our efforts, they were very delighted to support us, and they have volunteered to spread our product within the campus and place each of this product at VC's desk, director's desk, office desks, HODs, departments, medical institutions, the medical college, and wherever they currently use monochromatic printers. They're willing to take up our product and promote it within themselves, and thus also once it's completely populated inside our own campus, they're ready to facilitate our promotion to other campuses outside and schools locally in Tamil Nadu. Another way of spreading awareness regarding this product is what we got inspired from the technical community. We observed that certain companies, while spreading awareness regarding their product, used to release white papers which used to have a scientific analysis and a detailed description about their product and what kind of impact it makes on the customer and what kind of competency it has with respect to the other products in the market. So we realized that that's something that we can do as well. Once we have completely developed this product, we'll be releasing white papers where we are doing a completely scientific analysis and comparison of the performance, the actual economic impact that this product can make with respect to the other products in the market. So we'll be doing that, and we'll be spreading such white papers among the scientific community, among the academia community, and making people, intrigued about this product. Hearing about this product, we have seen a lot of excitement and a lot of anticipation. But people hardly realize the kind of effort and the kind of engineering time that it takes for making the product like this. Since the very working concept and the construction of this product is novel, unique, and something that has taken many trial and error for this perfection to be achieved, we have to be patient. It also demands a lot of investment of time, money of course, and also something called faith. We have to have faith on this product. As being engineers, the aim for us is to optimize the product such that it is affordable and also reliable as we claim. And at the same time, for ensuring maximum impact, we must be patient, as in terms that we must be patient for it to get perfect enough. Releasing in the market as soon as this product is developed is also not feasible. We'll be doing a lot of tests, we'll be seeing how reliable it actually is, and once it's perfected, we'll be bringing it to the world. And thank you.